Not too early, right? All right, good. My name is Steve Wolf. Ryan, are you back there? The rest of you come up forward scraping off the chart part. Any desire to experience that. So, when we set houses on fire in movies, we don't really like houses on fire because a real house burns down in about 20 minutes. And I need my movie house, especially in a case like Time to Kill, I needed that house to be on fire every day, 10 hours a day, for 3 weeks. So we have to make our movie houses out of materials that are non-flammable, which means things that don't burn, such as, in most cases, metal, right? So we make our house out of metal, and then what we're actually burning is the fuel that we plumb into it, and we use a fuel called propane. Propane is a type of fuel called a hydrocarbon fuel, meaning that it's made from 2 atoms of hydrogen and zirconium and carbon. So hydrogen, I think they need a napkin. So we've got this hydrocarbon fuel here, and we need to make some fire. So the way we're going to do that is by pulling together the ingredients we have to make fire, which are fuel, which is anything that burns, oxygen, that's the gas that we need to breathe to stay alive, heat, which is a form of energy, and a chemical reaction. A chemical reaction, of course, when we're taking the elements of 2 or more molecules, we rearrange them to make something new. So think it, he's super sorry. So if I had 3 elements here in my chemical, let's say I had C, A, and T, that would be what kind of molecule? A cat molecule, right? That's what cats are made from. But I could rearrange that if I had to. If I had to pin something to the wall, I could do a chemical reaction. I could turn them into a TAC, and I'd have a tack. Or if I wanted to go to Hollywood, I could rearrange them, and I could turn them into an ACT, and then I'd have an act. So I could have a tack, an act, or a cat just based on how I rearrange those elements to make different molecules. And it's the same thing in chemistry. So we're just going to rearrange the hydrogen and the carbon atoms in here, mix them with the oxygen, make something new out of it. So we don't use real fire on movies, of course, that would be incredibly dangerous. We use this special stuff here called movie fire. Here we go. And the difference between real fire and movie fire, of course, is that movie fire has been trained to work on a movie set. So if we're not filming downstairs, let's say we're doing a scene where like the twins jump out of a window and they each get their own window. I don't need the fire down here, so let's just go ahead up there and work with those windows. Thank you. And actually, we're not even filming over here, so this big fire here is like a complete waste. So we can just ask them to move over there. Pay attention right now. I need you to go over there right now. Thank you. Good. Thank you for listening. Okay. And this is exactly what I want from you. Okay, I just don't need it right now. It's just rehearsal, so I just want you to wait in the bottle. Back in the bottle. Thank you. Good. Good job. Excellent. So, all right, you guys know I'm just messing with you, right? You can't really tell fire where to go. It's a chemical reaction. As long as you have fuel, oxygen, heat, and chemical reaction, you have fire. Take away any one of those ingredients, the fire goes away. So of course what I was doing is I was using these valves here to close off the flow of fuel to where we did not want it. And when we took away the fuel, we stopped the fire. Now, a valve is a simple